You are listening to the AI World Podcast, your trusted source for the latest innovations, insights, and trends in artificial intelligence, blockchain, fintech, and decentralized technologies. Each episode features expert interviews, engaging discussions, and in-depth analysis of how AI transforms industries worldwide. Stay ahead of the curve with the latest articles and exclusive reports from the AI World Journal, covering everything from emerging technologies to industry breakthroughs. For more news, global events, and access to AI World Society circle gatherings, visit us at aiworld.tv. Don't forget to subscribe to stay informed, stay connected, and be part of the AI revolution with AI World Lounge. Thank you for listening.
Welcome to the Deep Dive. We cut through the noise, trying to bring you the ideas and insights that genuinely matter, helping you stay informed.
Yeah, really get to the core of things.
Exactly. And today we're diving into something pretty mind-bending. The just unbelievable speed of AI evolution. Picture AI's learning progress, right?
Okay.
It's not a curve anymore. It's like a vertical line, straight up.
It's a powerful image,
Yeah.
and it raises the central question for you today. What really happens when machines learn faster than nature ever intended? So we've dug into a really insightful article from the AI World Journal. It's called AI's Race to Learn, When Machines Learn Faster Than Nature Intended. We've pulled out the key ideas from there.
Right. And our mission here isn't just to rehash the hype. We want to look deeper at the surprising costs, maybe the hidden costs of this acceleration.
Yeah, and the big questions it raises for all of us for our future.
We're here to help you grasp the essentials, quickly, thoroughly, and hopefully give you a few of those aha moments.
Okay, so let's tackle that core idea first. AI isn't just learning like we might traditionally think of it.
Right.
It's evolving. Maybe accelerating is a better word, at a speed that it fundamentally challenges how we even think about cognition.
You mean compared to us, like biological brains?
Exactly. Think about it. Our brains take years, decades even, of development, learning, experience just to reach maturity.
Sure.
But the article points out that some AI systems, they're hitting really high levels of function mastery even in, days, hours, maybe even minutes in some cases. It's this radical compression of time.
Which brings us back to that vertical line learning curve you mentioned. It makes sense now. But how? How is this actually happening? Is it just dumping massive amounts of data in?
Well, data is definitely part of it, a big part.
Yeah.
But it's more about the way these algorithms learn. It's recursive.
Recursive.
Yeah, meaning they improve with data, obviously.
Yeah.
But each breakthrough feeds the next one, speeds it up. We're talking sophisticated stuff here, like neural networks training on synthetic data they generate themselves. Or using reinforcement learning to optimize their own strategies. Or even AutoML, which, lets AI design and tweak its own learning process.
That's pretty wild. The speed of actually mastering things is what gets me. The article mentions things that took humanity centuries, right?
Yeah, complex stuff. Language mastery, accurate image recognition, solving really intricate problems.
AI's doing this in months now.
Months, sometimes less. Think about large language models, LLMs, like GPT and the ones that followed.
Okay.
They train on these just unbelievably vast data sets, people say the entire internet, and they absorb all this nuance, the semantics, and then produce text that sounds incredibly human.
We've all seen that.
And it's not just language. Vision systems are outperforming trained humans in some areas. We're seeing autonomous systems that can design, write code, and even debug themselves.
Okay, so pulling this together, it feels like we haven't just taught AI how to learn. It's more like we've given it the keys to become its own teacher.
That's a really good way to put it. It's a profound shift.
But like any rapid improvement, especially on this scale, there's got to be a catch, right? A cost, something hidden.
There is. And it's huge. The article calls it the invisible ceiling for AI.
Which is?
Energy. Simple physical energy. It's this paradox. AI feels virtual, intangible, but its limits, they're very, very physical.
Ah, okay. So the bottleneck isn't just algorithms or data anymore. It's actual power grids, silicon.
Pretty much. Every single calculation an AI makes burns electricity. These models, they're getting bigger, more complex, running constantly.
So their energy appetite is growing. Not just growing, but you said.
Exponentially. It's growing exponentially. It makes you wonder, doesn't it? Could the physical world, the very thing that maybe forced our intelligence to develop slowly, deliberately, could that be the ultimate brake on AI's acceleration?
That's a fascinating question. What kind of scale are we talking about with this energy use?
It's staggering, frankly. The article mentions that training just one top-tier AI model can consume more electricity than, get this, 100 American homes do in a year.
100 homes for a year, just for training one model.
Just for the initial training. Then there's inference actually using the model day to day. That adds this continuous, ongoing energy demand across the globe.
And compare that.
Right.
What does the human brain use?
About 20 watts, like a dim light bulb.
Okay. And these big AI models.
They need entire data centers, massive facilities, pulling megawatts of power. Megawatts.
So the real limit isn't some abstract notion of intelligence, it's the infrastructure.
Exactly. It's the grid, the silicon, the cooling systems, and, importantly, the climate. All the physical stuff that underpins the computation.
Which puts us at a pretty critical crossroads, doesn't it? How do we balance this incredible acceleration with, the planet's actual resources?
That's the core tension. The source warns that if we don't manage this, AI could easily become the next industrial energy hog.
Consuming as much power as entire countries.
Just to run a few cutting-edge models. Yeah, that's the potential scale.
Wow. Okay, but surely people are working on this. There must be solutions emerging.
Oh, absolutely. There's a big push towards what people are calling greener AI. Lots of innovation happening.
Like what?
Things like neural compression making models, smaller, more efficient. Sparse models that need less number crunching. Edge computing, so processing happens closer to where the data is generated, saving energy.
Okay.
Neuromorphic chips are interesting too. They try to mimic the brain's efficiency. And of course, powering data centers with renewables. It's all part of the effort.
And are the big companies, the tech giants, involved?
Definitely. Companies like Google, NVIDIA, they're heavily invested. And startups too, like Cerebras. They're focused on making chips that are way more energy efficient per calculation. And what's really interesting is that governments are starting to clue in. They're realizing the AI race isn't just about algorithms, it's also an energy race.
With implications for, everything. National security, climate policy.
Exactly. It's becoming a geopolitical factor.
Can you give us a real-world example of this tension playing out?
Sure. Look at Cheyenne, Wyoming. There's a plan for a massive AI data center there. The projections. It could use more electricity than all the homes in Wyoming combined.
More than all the homes in the state.
That's the projection. And then you see the flip side. Amazon apparently had plans for data centers in Louisa County, Virginia, but they pulled back. Why? Significant local resistance, partly driven by concerns over energy and resource strain.
So it's not theoretical anymore. It's hitting the ground, causing real friction.
It really is. It's moving from a technical detail to a major planning and community issue.
Which leads us, I think, beyond the tech and the energy to something deeper, a more philosophical question, maybe.
Yeah, the article really pushes into that territory. It asks, basically, should we just be blindly accelerating intelligence like this without any constraints?
Because human evolution was slow.
Incredibly slow. Bound by biology, by the environment over millennia. And the question posed is, did that slowness actually allow for the development of things like, empathy, ethics, wisdom?
Qualities AI doesn't just automatically get.
Right. They aren't inherent in the code. So the uncomfortable question is, in our rush for speed, are we maybe skipping the evolutionary guardrails that make us human?
That's a heavy thought. And there's another concern mentioned about validating the knowledge AI creates.
Yes, the worry that AI could soon generate knowledge faster than we can validate it. Can it truly understand complex things like science or ethics or even human relationships?
Or is it just simulating understanding? A very convincing simulation, perhaps, but still.
Exactly. Simulation versus genuine comprehension. It's a critical distinction we need to keep wrestling with.
So ultimately, this isn't just an engineering problem or an energy problem.
No, the source frames it as a matter of collective intention. It really forces you to think about what we're optimizing for.
Are we building AI just for speed? Or are we aiming for something more like meaning?
That's the question.
Okay, so let's just quickly recap this deep dive. We started with AI's astonishing speed, that vertical learning curve.
Right, the sheer acceleration.
Then we hit the brakes, looking at the surprising and frankly huge energy demands that invisible physical ceiling.
The exponential cost.
And finally, we touched on these really profound ethical questions that this whole rapid ascent forces us to confront.
Yeah, the should we alongside the can we.
So looking ahead, the future of AI, It seems like it won't just be about how smart it gets.
No, I think the article argues pretty strongly that it'll be defined just as much by how responsibly we manage and channel its power.
It actually proposes a kind of new equation for progress, doesn't it?
It does, and it's quite powerful. AI intelligence, data, computation X, energy X ethics.
Data times computation times energy times ethics.
Yeah, and the crucial point is, if you ignore any one of those factors, especially energy or ethics,
The system becomes unstable.
precisely. It really challenges all of us, challenges you, to think about what genuine sustainable balance looks like as we keep pushing the accelerator on AI.
A lot to think about there. Thanks for joining us for this deep dive.
The future of artificial intelligence is unfolding, and it's happening at AI World Week, the flagship global event for innovation, collaboration, and transformation. This flagship global AI event is designed to connect visionary leaders, trailblazing entrepreneurs, and influential thinkers to explore the endless possibilities of AI. Experience groundbreaking technology that redefines industries and inspires progress. Join thought-provoking discussions on ethical AI, digital equity, and the transformative role of technology in our world. Build meaningful connections that catalyze innovation and drive impact. AI World Week is powered by AI World Society, a global movement dedicated to advancing AI responsibly and ensuring it serves humanity. Together, we're shaping a smarter, more inclusive, and equitable future. Continue your journey beyond the event with the AI World Journal, offering expert insights, in-depth analysis, and the latest trends shaping the AI landscape. This is your opportunity to lead, to innovate, and to transform the world with AI. AI World Week. We invite you to join us and embrace the AI revolution.